So behind you can see this huge vine plots here. We have 10 different vine taxa, and what's behind this project is we are having this increasing heat island effect. And in California, in Utah, where the population is growing rapidly and we are in rapid urbanization, a lot of big concrete structure being built in, and that is causing to increase the temperature. Through this project, we would like to see how the vines, ornamental vines, can be used to combat that urban heat island. We use these vines because they grow pretty fast compared to a tree, so that they have this nice canopy and then they can lower the temperature. That is one aspect of the project, but the other aspect is also to look at which vines are appropriate for our climate. Like, we have 10 different taxa, we'll be irrigating them to different water regimes, and we will know which plants need more water and which plant would need less water. And that way we can make a distinction on, okay, these vines will use less water and still have huge reduction in urban heat island effect. So that is one goal here in Utah. But as a whole, here you can see Lauren, he's a lead PI for the whole entire project, and we have this project at five different sites, from Arizona to Utah to Washington, and we have 6 different taxa that would be regional. Lauren, would you like to add something else?
Yeah, that's a really good description of the project. One of the, I guess, the initial questions was there's quite a few papers that show the benefits of using vines adjacent to buildings to mitigate heat loading and reduce energy requirements for cooling on buildings. So, but no one's looked at the water cost, and that's what this project does. It looks at how fast the vines will grow. It looks at light interceptions, but in response to the 3 different irrigation regimes, irrigation treatments that Chital described. So low, medium, high water irrigation treatments. And as Chital said, the vines grow very rapidly compared to a tree. It might take 10 to 15 or 20 years or more for a tree to get to a large enough size to actually maximize that benefit, that shading benefit, whereas a vine can take just a few years to shade a building. There are issues with vines. We selected these plants specifically for their characteristics of not being able to attach to buildings, because that weakens the structures. It has maintenance issues. So we looked at more vining, twining kinds of plants rather than, I don't know what
clinging type of
plants. They have specific morphological features that enable them to cling to vertical walls.
Yes.
We also looked at more deciduous vines, so that during the winter, they won't have leaves to actually benefit from the sunlight for warming the building, but then have the leaves in the summertime for the shading.
Yes.
Yeah. For us, it's really exciting because there's a certain amount of regional plants, so things that we're growing in all 5 sites, so we can see, are these plants good for the entire West? But there's also a good amount of local and plants that are maybe grown in 1 or 2 states. So that kind of helps speak to regional identity.
Said one unique identity of this project is also like the understanding the water footprint in relation to how much of cooling it can do. When you talk about the research being done, there is a lot of scattered research being done on how much or how cool or energy reduction can a vines do, but then what is the expense of water? That is usually missed in that equation. So we are trying to bring that in, and that way this project is very unique.